Good morning. My name is David Haskett and I am the CEO of Subterra. Subterra is a young UK company that has been developing CUI detection technology, uniquely using patented terahertz sensing technology, and it's passive. When we say terahertz, we mean that region of the electromagnetic spectrum that sits between microwave and the IR. For those of us who are not super technical, it can be considered akin to ultra long wave thermal, in that it's measuring a type of heat that's generated deep below insulative and cladding layers. For those of us who are old enough to remember the 1980s, you'll recall that scientists were concerned about the ozone layer. Down at the Rutherford Appleton Laboratory in Oxfordshire, a unique sensor was developed, which NASA deployed on a satellite, which was used to see through the layers of atmosphere and see depletion of the ozone layer beneath them. This resulted in the banning of CFCs. Fast forward to 2002, the same technology was tweaked. Instead of trying to see through layers of atmosphere, it was evolved to see through layers of clothing for security scanners that we're all used to now going through airports. A few years later, Subterra's founder, Joe Dunn, saw the technology, and Joe was an engineer, and he had spent many years in engineering and understood the challenges posed to industry by CUI. So Joe was on the lookout for technologies that could help. He saw the body scanners and he asked the question if the technology could be evolved to see through fibrous insulations and non-metallic claddings. He met Dr. Chris Mann, Subterra's founding CTO, who was involved in the development of the technology for the satellites and the body scanners. And Joe asked if the technology could be used to detect CUI. Chris felt that it could, and an idea was born. This is a moment I've been waiting for 6 years, just since I joined Subterra. And you know, every once in a while a technology comes along that has the potential to really change the way we do things. And I believe today is one of those days. We're showcasing STAR, the technology that we've developed in conjunction with the Net Zero Technology Centre's Open Innovation Programme. Now, many of you are involved in CUI, and you'll know that it's not a new problem. Back in ancient Rome, those bathhouses, the hot water pipes that fed those bathhouses were insulated with cork to keep that water warm. But chemistry is chemistry, physics is physics, and even though that was 2,000 years ago, those pipes corroded just like pipes do today. Anyway, Sarah has given you an introduction to our involvement and our history, but about a decade ago, Subterra developed its first prototype, which was called the B1080. It weighed 25 kilos, was the size of a suitcase, and gave you great exercise when you were bringing it around for field trials. The results were encouraging. The technology showed that it could detect CUI through insulation and non-metallic cladding. It could locate moisture, and it could be used to see changes in the underlying fabric layers. Those results led us to the NZTC, and in 2019, through the Dragon's Den process that Sarah mentioned, we began work on our first handheld technology. As Sarah said, that project, we took the weight from 25 kilos down to 7.5 kilos. You can see the unit here in the photograph, and this is being tested, as Sarah said, at Spirit Energy's Barrow facility. And we learned again that in a live environment, we could detect CUI, locate moisture, and analyze the fabric. But we also learned that the tool was too big. It was too heavy. It was the wrong form factor. So we set about learning about the problem posed to industry, the pain points. And when we would discuss traditional technologies or traditional methods with inspection engineers, the most frequent comment we got back was, it's okay, when they were talking about other technologies. And as we embarked on this project, this next project with NZTC, we wanted to do a little better than okay. We wanted to develop a system, not just a sensor, but a system that could really help the industry reduce costs, reduce risk, and safely extend the operational life of existing assets in the North Sea. I think it was Henry Ford who said, if you always do what you've always done, you will always get what you've always got. So we wanted to do something different, something new, something revolutionary. Now, as you know, NDT is a critical function to many sectors around the world, and quite rightly, a regulatory and certification system underpins the sector to make sure that there is a stream of highly skilled engineers that can use technologies, assess systems, and make decisions that ultimately save lives on a daily basis. Many of you here will know Subterra's technical sales manager, Mike Sim. Mike is a very experienced inspection engineer who has used many of the traditional methods and knows where they should be deployed and when and how to use them. But that said, the process of using the various technologies remains similar. A visual inspection may be conducted, work scopes are prepared, the technology is used to screen the asset, data is uploaded, processed, analysed, reports are generated and then circulated to wider teams to guide decisions. So while we were conducting the market research for this project, we learned that those highly skilled inspection engineers, at a time when, due to COVID, that there is backlog in the system, have to spend up to 60% of their time uploading, processing, analysing data and generating reports. So as part of STAR's objectives, we wanted to give the industry that time back. And this is at a time when, for a range of already widely publicised political reasons, the UKCS is under pressure to maintain profitability. So with STAR, we wanted to help the industry not only detect CUI, locate moisture and assess fabric, but also reduce costs, reduce backlog, and safely extend the operational life of existing assets. So this is the sensor that we developed on the STAR project. It's named Pi360, and it's absolutely packed with sensors. We've put our core, unique, patented terahertz sensing technology inside of it. We've put thermal sensors inside of it, metal detection sensors, positional sensors, and inertial measurement units. And these sensors come together to detect the CUI, the moisture, and assess the fabric, but also to monitor the use of the tool, how quickly the tool is being moved, at what angle the device is at while a scan is being conducted. And these come together to make sure that the tool is being operated correctly. We've developed Pi360 to be intrinsically safe, using a low voltage design, and we're on a pathway to achieving ATEX Zone 2 certification. And as Sarah said, we took all of the learnings from the first NZTC project and brought them into this sensor. We reduced the weight by 75%, bringing it down from 7.5 kilos to 1.85. We reduced the volume by over 60%, and importantly, we improved the form factor, making it much easier to be held whilst keeping your PPE gloves on. And it also, due to its shape, couples very tightly with pipework and vessels, but it also is low profile, requiring less free space around the asset that's being screened. The STAR sensor, Pi360, during the screening process, is wanded down the asset, and Pi360 sees immediately under the camera. So in order to scan an asset in full 360 degrees, for example, you would wand the asset down at various angles. Although our workflow software allows you to select a 6-point, 5-point, or 4-point scan, depending on your inspection strategy, just to reduce the inspection time. Anyway, the great news for Mike is that he's now working with Subterra, and the system he's using is STAR. STAR is an acronym for our solution, for our system, which stands for Scan, Track, Analyze, and Report. And the general premise of the system is that Pi 360, which is packed with all of those sensors, uploads all of that rich sensor data into the cloud, where our processing and AI kicks in, analyzes it, and clients can access that data in a secure cloud web dashboard. Now, when we say scan, what we mean is the generation of workflows inside the cloud software. The uploading of those workflows to this RealWear Z1 hard hat worn Android device. This is controlled using voice control, which connects via Bluetooth to the sensor. So the engineer would say, start scan, stop scan, those kind of controls. It also includes a 4 megapixel thermal camera and a 10 megapixel optical camera. So when the engineer is in the field, they can capture more data about the asset being inspected. It also includes a microphone. So as the engineer is at the asset, the engineer can record voice notes about what they're seeing. And all of that data, or when we say track, what we mean is using that workflow software and those sensors in Pi 360 to monitor the performance of the screening, to make sure that the device is being used correctly. If the engineer is moving the device too fast or is at the wrong angle, the software advises the engineer that there's been an issue and advises them to repeat the scan. When we say analyze, we mean taking all of that rich sensor data, both the quantitative sensor data, but also the qualitative voice notes, and upload them into the cloud, where the analysis begins. And when we say report, we mean instantly collating all of that data and making it available for export and circulation to your wider team. So let's take a look at it in action.
Showcasing Subterra Star, an integrated screening solution to reduce the cost and complexity of CUI.
Record voice notes. No obvious signs of installation damage. Suspected moisture at 6 o'clock. Take photo. Thermal camera. Take photo. Start scan 1. End scan 1. Save scan 1. Okay.
Automated analysis and reporting are available at the touch of a button via the Star Cloud dashboard. Welcome to the future of CUI detection with Subterra Star.
So there you have it. STAR is a revolutionary solution that detects CUI, locates moisture, and can assess the condition of the underlying fabric layers. It will help to reduce the costs and waste associated with detecting CUI. Because it's used to screen operational pipework, it will help to increase and maximize production uptime. And last but by no means least, because it's a passive technology, it's 100% human safe. So thank you all for taking the time to listen to my part of the presentation. I'm sure you can tell that we're excited to be showcasing STAR here today after all of the many years of hard work to get to this point. I'd like to thank NZTC for being a massive help for us on Subterra's journey to this point. And before Mike presents some technical data, some examples of STAR in action, if you have operational pipework with non-metallic cladding, please reach out to Mike or myself. You can get in touch with us via LinkedIn or the website or through the NZTC, and we'd love to schedule a call with you to see how STAR can help you. So thank you.
Okay, thank you very much. So I'm just going to take a little bit of time here just to run through some of the scans that we've gathered over the past few months. Hopefully that you'll find it interesting. If you've got any questions about the data, please feel free to ask any questions at the end. So just a little bit about me. I've actually worked in the inspection industry for quite a few years now. Worked both in NDT, pressure systems and asset integrity. I currently sit on the board of the British Institute of NDT, as does Connor. And as you can see there, I've held various roles in that sort of time as well. So I've actually worked in the tools as well, and I've also worked in operational management as well. Just a little bit about me as well. So when we're scanning, what is it that we're actually trying to see? So first thing that we're trying to find is the terahertz from CUI itself. So we're trying to find scabbing, corrosion effectively. Secondly, we're also trying to find, does the line have any moisture in it? And also lastly as well, that we're looking at the actual insulation itself, so is it crushed? Has it been damaged? So I'm not going to run through them, but here is a little bit of some of the scenarios that we've done, some of the insulation types, some of the cladding types, and some of the configurations that we have actually done over the past year or so. We are looking to expand this and also look at vessels and other applications as well. So what should a fully functioning pipe actually look like? Okay, so as you can see here at the top sort of aligned, it should have it should be sort of homogeneous. It should look quite nice. We shouldn't see any spikes in any data. You can clearly see here that we've got three black areas there. That is just actual banding that holds on at the insulation itself. This dark horizontal section in the centre there is just overlapping the cladding itself. Okay, but we're not seeing any moisture in here. We're not seeing any CUI. So what does actual CUI look like? So as you can see here on the left hand side, we've got a test rig that's got 4 known scabs. These scabs are roughly 6 mil in height by about 80 mil wide. We clad it in FlexiFoam, 2 sections of 25 mil and 2 millimeters of vulva. If you look at the actual data set here, we can clearly see that the scabs are showing up. Yep. We can clearly see that we've also got spikes in the data set itself. You'll see that we've got these dark horizontal lines as well. These are just the areas of tape. So myself and Matt had actually taped them up, and we're seeing that as well. So therefore, you're seeing any dips in the actual data set itself. So this was a 6-inch OD line, clad with aerogel and GFRP. Again, we can see the banding showing up. In the dark purple sections, we're seeing that the actual metal's fine, but in that dark section, we're clearly seeing some CUI there. Now, unlike other NDT methods, we are now starting to see the early signs of coating breakdown, so the early stages of CUI, which you don't get from any other NDT inspection method, sorry. So this is my FlexiFoam line. Again, it's a 6-inch OD, 50 millimeters of Armaflex and Armacheck. Again, we can see areas that the actual line is fine itself. We've got some moisture integration there. So any moisture shall show up in black in the data. And we've got one area of CUI just on your right hand side there. So it's quite clear. Again, if you take note of this line here, that we should see no actual variations in the line itself. Yeah, it should be homogeneous. This is a mineral wool line. Again, it's a 6-inch OD. This is quite a busy slide, as you can see there. We've got the horizontal lines there, which is your metal banding. We've got darker sections here that is showing the overlap of the cladding itself. This line had some actual moisture by the client, had actually injected some of the moisture. And we can see them here, which was 25 mils, and this one here was 50 millimetres of water. And we also sort of found 3 areas of scabbing as well. 1, 2, 3. So CUI is quite present there. And I'd be glad to take any questions on the data if you've got any.